Welcome everyone to our virtual exhibition booth. Today we have a number of items that we want to cover in our exhibition booth. Right at this moment, we're going to start with our webinar on the highway capacity analysis and what we have in HCM6 edition, as well as touching some of the upcoming material for HCM 6.1, which is going to be released next year. So with that said, let's start our webinar and the overview of what HCM Highway Capacity Manual is about and what are the methods that it has, especially in the latest version, which is the 6th edition of the HCM. And also we want to maybe touch base on the upcoming methods that's going to be in the next version of Highway Capacity Manual. So my name is Behzad Akdashi. I'm the director of McTrans Center at University of Florida Transportation Institute. I'm also a Highway Capacity Committee member. This is the committee at TRB that oversees the content of HCM and basically approve the content as it becomes available through national level research studies like NCHRB. I have been involved with HCM and the methods on the research projects, developing its methods for more than 10 years. And I was part of some of these projects that we eventually developed material and we got the approval to be included in the HCM. Assisting me today is Fabio Sasahara. He's associate engineer at McTrans Center, and he has experience of developing materials for the highway capacity manual. Specifically, he's gonna actually hold a session for us in our exhibition booth at 3 p.m. today regarding the new systems method that enables the integrated, analysis of a corridor that consists of arterials as well as freeways. So with that said, let's see, what is, all right, so I see a comment here on the chat box and I want to appreciate Anush for pointing that out to us and Fabio for correcting that. Yes, our email address is mctrans@ce.ufl.edu. So what is Highway Capacity Manual? Basically, HCM is one of the widely used reference materials for transportation engineering. It has methods that can analyze freeways, arterials, different intersection types, signalized intersection, roundabouts, stop control. It has methods to analyze different alternative intersection types like ARCOT, MUTs, as well as interchanges. Different interchanges type can be modeled with the methods that there are in HCM. All of the methods in HCM are predictive, meaning that once you provide information, such as including geometric information as well as demand, it will basically simulate and model what would be the traffic condition in a macroscopic way on the facility. And it will generate a lot of performance measures like speed, travel time, delays, and queue lengths. And based on those, whatever HCM decides is the service measure, it provides eventually our level of service and LOS. This content has been basically in a repetitive mode is reviewed and overseen by Highway Capacity and Quality of Service Committee at TRB. Basically, this committee meets once at the annual meeting of TRB in January, and then once in the summertime as a mid-year meeting, and interactively and proactively, basically, they are looking for basically the content. Sometimes there are major updates, such as whenever a national level, projects such as NCHRPs finishes that develop a material, basically they deliver it to this committee for approval, and this committee basically reviews that content several times. It returns a comment back to the project teams and they address it, and at the end they basically the voting, version chapter of the HCM content goes for this committee for approval, and they most of the times they approve it. So not only major updates are the things that this committee is in charge regarding HCM. This committee also works with practitioners. They gather information about errata, and sometimes there are some mistakes in HCM that basically they look into that, they fix that, they vote on that, and then whatever decision that this committee makes, basically they let TRB know about that decision, and TRB is the unit that basically makes the publication of this material. So there are 6 major versions of HCM starting in 1960s up until now, and the 6th edition, which is the most recent version, is entitled as a Guide for Multimodal Mobility. And the reason that basically this committee has decided to name HCM 6th edition as with the 6th edition Guide for Multimodal Mobility is that because we want to highlight that HCM today is not all about motorized vehicles. It has methodologies to analyze level of service for pedestrian and bicycle as well. Previous versions of HCM, there was a year attached to that, like HCM 2010 or HCM 2000, but this last one, which released in 2016, in order to highlight this multimodal capability of HCM, it's not named, it has not named HCM 26, it's HCM 6th edition. So with that said, let's take a look at some of the concepts, especially about LOS. All the methods in HCM, if you follow from beginning to end, they basically at the end, they report level of service. So as most of you guys may know, level of service is quantitative, stratification of performance measures that shows what is the quality of operation of a facility. And facility could be just a single point facility like an intersection, could be urban street segments, arterials, could be multiple, urban street segments, could be freeway, a merge or diverge, segment. It could be the entire freeway. It could be a single day type of, analysis, could be a whole year, multiple day type of reliability analysis. For all of those basically generates, a lot of performance measures, specifically service measure along with level of service. And basically this level of service, the way that it works is that it makes it easy to understand how well the facility is operating. Apart from, understanding, what are the service measures that best represent the driver, perception of the quality of the facilities. So with that said, here on this slide, I'm showing all the service measures that we have in HCM and how we define LOS based upon those. As you can see, for most freeway analyses for motorized section, we have density as the representative performance measure, or in other words, service. It's our service measure that represents how well these facilities are operating and what are the drivers' perception about this. And then if we move on toward intersection type of facilities that we have here, signalized intersection, two-way stop control, always stop control facilities, and roundabout, we can see that the delay is basically the service measure in order to identify the level of service. For urban streets and urban street segment, as well as urban facility, basically speed is the best indicator in HCM's perspective to represent the level of service. So there are a lot of other, service measures that I don't want to go into them, especially for pedestrian, bicycle, and transit. We characterize them. We have methodologies for some certain facility types, and LOS score is primarily the the service measure that we use to characterize their level of service. So with that said, right now we know what HCM is about and what type of analysis, big picture, it proposes us to perform. Let's take a quick look at the history of HCM. Basically, the first edition of HCM released in 1950. That was the first version. Basically, sort of got sponsored by Bureau of Public Roads. Then 65 Highway Capacity Committee formed, and then it basically it was overseeing that version, and they published that in 1965. Then we had other major versions, 85, 2000, 2010, and at the end in year 2016 is the version 6 edition that is the most recent one. As you can see, we are also highlighting some of the big changes that we had, through time on the way that we have developed the content of HCM. In 85, that was one of the years that there were a lot of research sponsored from TRB, NCHRPs, and Federal Highway Administration that they found their way coming into this manual in 85. Then in year 2000, we had this complete reorganization. We had these 3 volumes sort of format. And then in the 5th edition, 2010, we had a lot of research actually going into the HCM, as well as that was the year that we saw some of the engines called computational engines also formed to sort of bypass all the complexities that we have in terms of computations of the methods in the HCM. And then in the 6th edition, again, it was a lot of other research that they found their way into the HCM, and it became at 37 chapters. The reason that I say it became is that because there have been, since 2016, there are a few major national level projects that they have been finished, and their material to be included in the HCM have been voted on, and one of them is going to generate another chapter 38. So with that said, all those research projects that primarily NCHRPs that they generate material for highway capacity manual, there is another typically in order to construct this major editions, major versions of HCM by itself, that's another big national level NCHRP project. For HCM 2010, it was NCHRP 392, and for HCM 6 edition was NCHRP 3-115. That it kicked off in August 2013. I had the honor to be part of that project team for 3 years to basically start from HCM 2010. Consider all the feedback that we have got since 2010, and then embed all these new research projects in the years of 2010, 11, 12, 13, and amend them, all of them, into the 6th edition. Basically, that project started in 2013. It finished in 2015, and all the chapters went to the publication through TRB in 2016. It was fall 2016 that the latest version got published. So let's take a quick look at the projects that they found their ways into different versions of HCM. This sort of gives an idea of what are the methodologies that a highway capacity manual covers, and so on. So for HCM 20, I'm going to start with HCM 2010. The bigger contributors to that was 8 NCHRP projects that are covering methodologies for interchanges, for HCMAG or Highway Capacity Manual Applications Guide, which is the material in the Volume 4 of HCM. We are going to talk about that a little bit more in details later on in following the slides. For the first time, roundabout methodology got embedded into HCM. New urban streets, multimodal methodology, get into HCM 2010. New freeway weave segment methodology out of NCHRP 375 found its way there. And then another project on urban streets, another project on alternative tools, primarily, simulation. It's interesting, HCM consists of all, these macroscopic type of, methods. And, sometimes there are times that, the facilities that we want to analyze, you cannot really analyze it by the HCM, just because sometimes we have this, non-typical type of geometric configuration, or something is off, compared to the scope of analysis for different methodologies in HCM. And that is the time that actually HCM characterizes alternative tools, primarily microscopic simulation. And it provides guidance on when we should walk away from HCM content, when should we go and use simulation. If we want to use simulation, then what are the things that we need to consider in doing the simulation work? Because when we are going to come back into HCM world and we want to try to see what is the level of service, we need to make sure that we are doing the simulation right, the way that basically HCM wants to, so that, at the end, when we are designated level of service off of something that has been analyzed in the simulation world, it become truly representative of the actual level of service. And then at the end, a major NCHRP project, 392, that put together HCM 2010. The same story, a similar story, goes for the 6th edition, where primarily contributing national level projects that generated material for that included a few NCHRP projects, a few like ones that funded through Federal Highway that basically generated methodologies for managed lanes, HOV lanes. That's something that HCM6 basically was able to conduct that. Another project on the roundabout corridors, basically it looked into how we can analyze corridors with roundabout. Previously, it was just roundabout as a single point that we were able to analyze it via HCM 2010. And also it looked into new capacities for roundabouts, because roundabouts, they're pretty new in the United States. At the time that the first NCHRP project on the roundabout capacity performed, there were some capacity numbers, measured, and honestly, it was hard to measure just because most roundabouts they built in locations that they barely, experience operation at capacity. And then, people in the United States through years, they learned how to drive through roundabouts and maybe in a quicker way, which results in a higher capacity for roundabouts. And then NCHRP 3100 basically also looked into these capacities. So capacity numbers, and not the method, capacity numbers in HCM 6th edition is much higher, 20-30% higher than what we had in HCM 2010. We have new work zone methods, both for freeways as well as urban streets, active traffic and demand management analysis framework for both freeways and urban streets. These are new items in HCM6, as well as planning guide for HCM and NCHRP 7-22 that generated a lot of planning level analysis, like maybe more high level that you don't really need to use any software for. You can just do the computations by hand and get a rough idea on how well different facilities will perform. Then we have this new methodology for alternative intersections, as well as travel time reliability, funded through Strategic Highway Research Program Round 2, Project LO8. And maybe this was the driving factor to develop HCM6. This was maybe the biggest project that was contributing to the HCM. And US DOT and Federal Highway has been pushing since then to use travel time reliability as a measure for prioritization purposes that the different state DOTs are doing in different states. And we are going to talk a little bit more on that, what that means, what are the differences between reliability analysis versus a single day typical day type of analysis. We have new truck procedure with new truck PCEs, as well as a sophisticated method called mixed flow model, primarily for freeways. And then at the end, NCHRP 3115 was the project that took all these project. Of course, these are the list of big projects. There have been maybe smaller ones that are not listed here, and they developed HCM6 edition. By the way, I forgot to mention this. Another motivation to go with like the HCM6 as opposed to having a year next to HCM was that when we have new projects coming in and we want to update a few chapters, not the entire HCM, we should be able to just update those chapters and call it HCM 6.1, for example. That was another motivation that kicked in, and we basically walked away from the year designation for different HCM editions and went with the edition number. So I think this will be the interesting section, and that is the research projects that have been done since HCM6 edition got published. And basically, we are waiting for HCM 6.1, basically to be published in 2021 or 2022. Highway Capacity Committee has already approved some of these chapters. Basically, for example, NCHRP 17-65, Multilane method. This chapter, this research project has ended a couple of years ago. Proposed HCM chapter has been proposed. Capacity Committee has been reviewed that, and basically we have got a vote to be amended as part of HCM. And some others are coming as well. So basically that chapter 15 for Multilane method, we have version 6.0 as well as 6.1. So let's take a look at some other projects that have been ended. Around year 2016-17, a Federal Highway Administration funded project ended, and a new urban streets active traffic and demand management project basic methodology got generated that enables us to analyze, for example, this active traffic demand management in urban streets. Strategies such as reversible center lanes, dynamic lane grouping. These are basically methods that right now we have within HCM. Of course, not within HCM6, but it will be added to the HCM. NCHRP 17-85 generated new pedestrian LOS service methodologies, a revised one. There is an ongoing project, NCHRP 7-26, that is developing new material for freeway merge, diverge, and weave methods. Basically, chapter 13 and 14 of HCM that, they talk about merge, diverge, and weave. Whatever we have is going to be changed in about a year or two, whenever that project ends and material becomes available. So we have another basically ongoing project. Maybe I can say it just finished, that basically generated capacity adjustment factor for CAVs. A lot of times we use HCM to use their predictive models to see how well if different facility types are operating. But a lot of time, what happens is that a lot of people, they refer to HCM just to look into capacity numbers. For example, if I have a freeway with 60 miles per hour free flow speed, what is like per lane capacity, in a ramp segment, because for example, they want to just get an idea like how many lanes do they need to serve their demand. And from that perspective, actually, some sort of indication of like how much increase our facilities will have if CAVs actually enter our, traffic flow. So this project has come up with some capacity adjustment factors to all the capacities that we have at the time, that for different penetration rate for connected and autonomous vehicles. We have another project that has ended, and actually we are gonna NCHRP 1557, and we are gonna have a detailed actually workshop at 3 p.m. just covering the new systems method in HCM. This was a project led by University of Florida, and it just finished, and new chapter 38 is available. Of course, Highway Capacity Committee is looking into that to review that and provide basic their feedback before going into the voting process and getting the approval. And Fabio, who is assisting me in these sessions, is going to lead a presentation and a conversation in webinar format at 3 p.m. talking about the details of this methodology. This methodology, for the first time, will enable HCM users to be able to analyze a corridor that is consistent with ramp and freeway. Basically, we can start from somewhere on arterial, go to an interchange, take the ramp, go to the freeway, and then maybe take an off-ramp and go to another arterial. From that start point to the end point for this mixed type of facility, we can provide analysis, predictive analysis, and evaluate how well they are operating. There are two projects that they have not been started yet, NCHRP 1566 and NCHR 398A, that hopefully maybe this year, next year, they'll start, and they will basically provide us with arterial weaving method, which is very demanded, especially with all these alternative intersections. In ARCADs, we see a lot of arterial weaving nowadays than maybe 10, 20 years ago. Previously, it was mostly on the freeway facilities, but nowadays we see a lot on the arterials as well. As well as there is going to be a new freeway oversaturation methodology project focusing on developing this, primarily to address the intersection of HOV lanes with the freeway mainline lane. HCM currently provides this oversaturation analysis, meaning that in our freeway analysis, we can have multiple time periods, we can have bottlenecks, either active bottleneck, either hidden bottleneck, and queues can form whenever our demand goes beyond capacity. So we can do all these, but we cannot interact it with managed lanes. For example, whenever we have this oversaturation in the mainline lane, how well the managed lane, those access segments, they're going to operate, or if they're going to be some queue spillback from possibly from general purpose lanes to managed lanes, how that thing is going to basically form and how we can evaluate that. So this was a highlight of what are the things that we are expecting to see in the next version of HCM, primarily 6.1. So as you can see, there have been a lot of research going into highway capacity manual, multi-million-dollar peer review, national level research projects. And really this sort of justifies why HCM is one of the widely used reference materials. It's heavily reviewed material, both from the panel of the projects that they do these NCHRP type of project, as well as highway capacity committee. And then year by year, methods, they get more complex. And in 85, we had most of the methods were simple. You can just use a calculator, a sheet of paper, and a pen, and do analysis. But in year 2020, they become more and more complicated. The use of software actually become inevitable, meaning that nowadays, especially with the reliability, analysis, as well as facility level analysis, both for urban streets and freeway facilities, there's no way that we can do these by hand. So we talked about what HCM is, what are the different versions, what are the methods that recently in past 30 years has found their ways into that. Let's talk a little bit about its organization so that all of us will get a same understanding of how it's organized. Basically, HCM 6th edition has 4 volumes, volume 1, 2, 3, 4. First 3 volumes named Concepts, Uninterrupted Flow, and Interrupted Flow. They are hard copies. Either we can, of course, TRB right now sells PDF, but we can go for paper copy as well. But the thing is that basically we need to purchase it. It's not free. Then volume 4 is a just online volume. It's only is in a PDF format, and it's housed in the HCM volume 4.org website, and it's free for everyone to access. You just need to make sure that you have a user registered on HCMvolume4.org. But again, that's free, and then you can join HCM Volume 4. So then we have a new organization within HCM content moving into HCM6, and that is the fact that in HCM 2010, pretty much each chapter, it had its own organizations, meaning that, either it was like introduction, concepts, methodology, application, examples. It was different than other chapters. And over there, pretty much, I think it was year 2012 or 2013 that this new ramp terminal chapter basically got published, and it had this outline of introduction, concepts, methodology, and then extensions to the methodology, applications, and references. And then in HCM 6 edition, this got adopted actually for all the chapters. So if now you look into chapters, primarily chapters with methodological information, primarily in volume 2 as well as volume 3, you see they all have this organization that it starts with introduction of what this chapter is about, what are the scope of analysis, what are the limitations. Then it goes into the concepts, making sure that the readers are familiar with the concepts related to the methods that we have in that chapter. Then it goes into the methodology for motorized and, if applicable, for pedestrian and bicycle. What are the steps that users need to take, and at the end, how they can measure level of service. And then depending on the material in each chapter, sometimes we have the extensions to the methodologies. For example, chapter 12, that kind of basically includes our methodology for basic freeway segment. We have the extension section that extends all the methods in order for estimate speed and all those sorts of things to do it for HOV lanes and managed lanes. And then we have the application sections that looks into some of the maybe more of a things related to applications. It has some materials such as is sensitivity graphs to different design parameters, and based on the methodologies that are they are within that chapter, how changing different elements, how they can result in different performance measures. And then at the end we have references. Another standardized content that we see in HCM 6 edition is that for every chapter that we have methodological content in it, we have a table that summarizes all the inputs that are needed. And this was one of the big comments that we received in year 2015-16 when we were developing HCM 6 edition, that such a table helps a lot for the users at the beginning to see what are the required input data in order to basically invoke these procedures. Because if users, they don't have access to these data, or if they can't use defaults here, they will not be able to use these methodologies. And before we bombarding them with all these details and complex equations and process flows, we want to lay out to the user that what are the inputs that we need, where are potential sources that users they can go about collecting these data, as well as if users they can't do the data collection, if they can't get these data, what are the default values that HCM suggested that they can use in the absence of access to the real world data. And we have this table pretty much in every chapter that we have methodological content in it. Again, I was just talking about that a couple of slides ago. Every chapter has example results that show some of the select parameters and their sensitivity basically the sensitivity of the method to these parameters. Another standardized thing that we have in HCM6 edition is that all example problems, right now they're in volume 4. Previously in HCM 2010, example problems, they were part of methodological chapters in volume 2 and 3. But in HCM6 edition, basically all of these, they migrated into volume 4. One of the big motivations for this was that there was a limitation, the number of pages that we can have in volume 2 and 3, and there were a lot of material that NCHRP 3-115 project wanted to embed off of all the research projects that we just. So we had to make some room in volume 2 and 3. So we took out all these example problems for all the chapters that we have in volume 2 and 3 and basically put them all in volume 4. Another motivation behind that was that volume 4 is online. It's easier to edit it. If committee find mistakes in computations or anything basically related to the numbers, detailed maybe sequential or interim results, it's easier to adjust those and correct those in the electronic version as opposed to the hard copy version of volume 1, 2, 3. So let's move back to the organization. Let's take a quick look into different chapters that construct HCM. So our volume 1 basically is named Concepts, and it has 9 chapters into that. And these chapters, they cover different things from, these some of the concepts related to traffic flow theory, what are some of the concepts related to the quality and level of service, guidance on the use of alternative tools and simulation, and primarily in chapter 6. So it has some material that overall, if someone wants to execute HCM methods, they need to be aware of these concepts in volume 1. But then volume 2 and 3, they provide the methodological chapters that they have methodology, so that we can use them in order to see how well facilities are operating. Volume 2, it's named Uninterrupted Flow, basically, and it has methodologies for facility types that we don't have interruption in the traffic flow. Primarily, it's going to be freeways and highways. So we have, if I want to go over them, we have methodologies for freeway facilities, we have methodology for travel time reliability analysis, and then segment level chapters for basic, merge, diverge, as well as weave segment. And at the end, we have methodologies for 2-lane highways as well as multi-lane highways. Then in volume 3, we have chapters related to facilities that we see some sort of interruption in the traffic flow. And primarily it consists of urban streets facilities, urban streets analysis in the form of travel time reliability or the whole year type of analysis. Then we have different intersection type methodologies on chapter 19, 20, 21, 22 for signalized intersection, two-way and all-way stop control intersections, as well as roundabouts. Then we have methodologies for ramp terminals, interchanges, alternative intersections like ARCAs, MUTs, etc. And then volume 4, which is online and it's free for everyone to access. Basically, it has supplemental material to the all HCM content that we have in volume 1, 2, and 3. And I'm listing here the chapters that right now we have in volume 4. Again, there is a new chapter coming in, chapter 38, which will cover systems method in HCM, that for the first time we are going to have basically a route that consists of urban streets and freeways, and this methodology will enable us to analyze those. We are going to have a detailed presentation and discussion at 3 p.m. in our exhibition booth covering that upcoming methodology in the highway capacity manual. So let's take a closer look into volume 4 of HCM. I just mentioned that this is free material. It's available for everyone to access it. Of course, you need to create a user. The URL is hcmvolume4.org. Once you go there, you need to create a user. It's free. You need to sign up so that when you sign in, you have access to all the content in HCM Volume 4. And actually, HCM Volume 4 is not just chapters, supplemental chapters. There are some other sections within Volume 4, such as technical reference library and then applications guide. That these are additional, they provide additional information in regard to methodologies in HCM. So let's take a quick look into these contents in HCM Volume 4. We have supplemental chapters that I just went over them. All the example problems that I just mentioned, they're right now part of these supplemental chapters. Then we have technical reference library that basically has all the material that exists that relates for every chapter in HCM. This library basically lists them out. And it consists of like final reports of the projects that had led to the publication of this material in these chapters. It has computational engines, and it has some papers that are referenced in the chapters in Volume 2 and 3. Then we have applications guide that basically there are two NCHRP basically projects that has created these applications guide. One of them is planning and preliminary engineering applications guide to the HCM that provides some planning level methods consistent with HCM to sort of do a quick analysis of the operation of different facilities. And then we have also HCM applications guide, or HCM MAG, that provides 6, if I'm not mistaken, 6 case studies of how we can use HCM methods in real world application, how we can go about collecting data, how we can go about interpreting the results, looking to performance measures, and all those sorts of things. It's recommended for the users to take a look into these two documents. So with that said, I have this slide here that I want to highlight highway capacity software. So what is HCS? HCS is the highway capacity software that faithfully implements all the methods in the HCM, ranging from interrupted flow to uninterrupted flow type of methodologies, freeways, streets, intersection types, roundabouts, and so on. It has been version 1 basically developed in 1980s at McTrans Center, University of Florida. And since then, this software has been updated in a very frequent way. Typically, we have 2 updates, 2 sub-version releases every year since 1980s. We are working closely with Highway Capacity Committee. We are attending all their meetings. We are watching all the changes that are coming to the HCM methodologies. When there are even small changes, into HCM like errata, we immediately after all these meetings, we come back and we implement those in HCS to make sure that users that are using HCS, they are ensured that they are doing analysis, compliant with HCM methods. We do have a very strong user base worldwide, over 15,000, about 15,000 installations worldwide, and it's over 1,500 companies and businesses that they use HCS to basically conduct HCM analysis. As I mentioned, HCS started in 1987 actually. That basically at that time we implemented methods in HCM 1985. Version 2 in 95 implementing material that went into HCM 94. And then if you see that primarily for every major release of HCM, we have a new major version coming in. And again, these are like major versions. Every year we provide 2 sub versions to account for all the changes that have been happening there. Pretty much 6 time period, as well as all the bugs that we get reports on from our massive customer base. We take them seriously. We want to fix them quickly in a timely way. And basically every 6 months that you get a new version, pretty much all the bugs that have been reported for us, for all the methods in HCS have been fixed. So what HCS can do, basically whatever HCM offers, HCS can do. If I want to highlight what are the analysis type that HCS can do, maybe I can start with Freeways. And basically HCS can do segment level analysis. If you're interested to do, for example, you have a Weave segment that you want to analyze and see how well, you know, if you want to do a treatment into that, how well your level of service is going to be changed. If that's a merge segment that acts as a bottleneck, you can analyze that. It can do segment level as well as facility level, you know, analysis, where we can have multiple segments next to each other. That, for example, one of them can act as a bottleneck, and a queuing can, you know, constructed behind that bottleneck. It can analyze all those. It can do multi-period analysis, account for the time that, you know, this queue grows and queue dissipates, and it can account for all those, you know, delays incurred by congestion and freeways. It can do travel time reliability analysis, looking into basically freeway facilities, not on a single typical day of operation. It can look into the operation of the facility in a year long, with all these, you know, non-recurring sources of congestion that may occur, such as incidents, severe weather events that can happen. It accounts for all those and can basically show you the travel time distribution, and can also list all the reliability level performance measures that we have, such as PTI, 95th percentile travel time, such as LOTTR, level of travel time reliability, and so on. We can do a work zone analysis on freeways. We have methodology to account for the capacity loss as well as change in the free flow speed on the work zones on freeways. We can do managed lanes, model managed lanes, HOV lanes, and see how well they can help operation of the freeway facilities, as well as we can model some ATDM strategies in our basically within the HCM context, such as RAM metering, hard shoulder running, incident management, and traffic diversion. So that was about freeways. What HCS can do for urban streets is that we provide all intersection analyses. If you have a roundabout, stop control, or signalized intersection operating in a coordination with others or not, HCS provides basically modules to analyze each of those. And again, you know, all the inputs, outputs are the things that, you know, HCM requires. Of course, we provide some default values based on the guidance of HCM, and we always recommend users to learn more HCM to better interpret the results. Along with traditional intersection types, we can model alternative intersections such as ARCOT and MUTs, as well as interchanges. That one example would be DDI, and for sure we can do basically arterials, you know, basically urban street segments, and, you know, that construct, you know, arterials and urban street facilities. We can model those in HCS, and of course we can take a look into year-round type of, you know, analysis framework, and look into the reliability and include non-recurring source of congestion into the blend. So some important resources in regard with highway capacity manual and HCS. One is McTrans Center's website. We always post all the upcoming, material regarding HCS, all the users guides, all the events happening around that, all the webinars and trainings that we have. We provide a very extensive and pretty like massive training, series throughout the year. We are happy to train about 500 people and every year on the HCM content. And we do webinars, online sort of, training, which by the way is the only thing that we do at the time of pandemic. But we also hold classes, in different locations in the nation as well as overseas. We hold classes overseas as well. So if you have any needs, if you either for yourself, if you want to get training, or if your organization needs some training in regard with HCM, HCS, we are happy to basically talk to you and see how we can best support you. Another resource that always I want for you to know is our email, mctrans@ce.ufl.edu. If you have any question about HCM, if you have any question about HCS, feel free to send us an email. We have a group of HCM subject matter experts at McTrans Center, and we take our basically technical support actually line very seriously. If you send us any questions, it's maybe a matter of hours that we get back to you. At most, it's going to be maybe about a day. And then the last thing that I want for you to remember is our LinkedIn page, McTrans Center LinkedIn page on LinkedIn. That's where we are also sharing some of the details of what we are doing. If any material that is, in regard with the world of, HCM type of analysis or HCS, over there we have this page too that we post different materials in it. So this was what I had as the overview of, HCM, what HCM is, and, basically what type of analysis it provides. I have a few follow-up slides that I want to take advantage of some of the time that is remaining and go over them and basically maybe in an example format show you what type of really analysis the HCM can provide. So I'm going to go over both freeways and streets basically to account for uninterrupted flow and interrupted flow type of facilities, and basically one by one look into that and highlight what are the things that we can analyze in HCM, maybe as opposed to simulation, micro simulation, etc. So for freeways, as I mentioned, we model queues, we can model bottlenecks, we can model active and hidden bottlenecks within HCM. For those of you who don't know what is active and what is hidden bottleneck, is that if you have multiple bottlenecks within your freeway, sometimes because of the traffic metering that happens on the first bottleneck upstream, you don't realize that you have another bottleneck downstream. Basically, your demand gets metered upstream, the volume that can pass through that is much lower, that your second bottleneck really will not create any queuing. But if you make a treatment, fix the first bottleneck, this will increase the vehicles that will pass from the upstream section, and basically it will trigger the congestion in the second bottleneck. Second bottleneck is what we call it a hidden bottleneck. So you may not see it on the daily operation of the freeway if you want to look into the actual operational days of freeways, or if you model it even in any in HCM, you will not see the problem. But if you want to fix the problem in the active bottleneck, basically your hidden bottleneck will be activated. So HCM helps you to identify those. Basically, hidden bottleneck is what HCM defines as a location that your demand over capacity is higher than one, but basically your actual volume passing through that location divided by capacity is less than one. So HCM provide means to identify those and keep that in mind when we are thinking about scenarios of fixing the congestion problems on the freeways. So as I mentioned, HCM enables us to model HOV lanes as well. Big picture, we call them managed lanes. It could be HOV lanes, it could be express lanes. There are 5 different actually managed lanes that we can model in the HCM world. And basically, the way that we are defining those 5 HCM managed lane segments is that we are including the separation type as well. So we have this marking type of separation, buffer separated, and as well as barrier separated. And for buffer and barrier separated, we have either 1 lane managed lane or 2 lane managed lane overall, constructing our 5 basically managed lane segment types. So we have a methodology to model work zone as a function of different parameters that we have for work zone. We can compute the capacity loss that we are going to get because of work zone, as well as what is going to be our free flow speed. Those are things that we can model it in HCM. Travel time reliability is one of the unique methodology types that we have in HCM, that we can do in HCM that I don't think we can do it completely in other maybe methodologies or different softwares such as microsimulation, type of environment softwares. And that is and basically how it works is that in HCM, when we want to look into how reliable our travel times is, the HCM methodology creates a number of scenarios, each representing 1 operational day of our facility. And it has a methodology called scenario generation that assigns, this fluctuation in the demand, different incident types that, results in lane closures and stuff, work zones, severe weather events on top of each scenario, in a way that, these scenarios best represent a year worth of, operational facility. And it analyzes each scenario the same way that we analyze a single day type of, operational facility, and we collect all travel times that we see. Off of this process, we put them all together. It will create a distribution of travel times for us, and then we have a number of performance measures that are defined based off of this travel time distribution. We can model multi-lane highways that typically these are urban streets with long lengths, typically more than 2 miles. When you have more than 2 miles, the distance between 2 intersections, that link is called multi-lane highways, and we have HCM provides methodologies to analyze this. We have 2-lane highways method. We can analyze 2-lane highways. We just had a new methodology being approved by committee last year that provides a modified version of this 2-lane, highways methodology. We are not characterizing facilities by, different classes in the new method. But overall, basically, it gives, more capability and more accuracy to the way that we are analyzing 2-lane highways. HCS actually offers both methodologies. If you open HCS, if you go to the 2-lane highway module, it asks you whether you want to have 2016, which is HCM6 version edition of 2-lane highway methodology being that module to be invoked, or 2019, this new and basic methodology that just got the vote to be included in the HCM. We can model stop control intersections, both 2-way stop control, all-way stop control. We can model intersections with 3 lanes in HCM world. We can model roundabouts in the HCM. As I mentioned, HCM 2010 and HCM 2060, they have a very different, capacities, assigned for roundabouts. just make sure that whenever you want to grab HCM to look into capacity numbers for roundabouts, you go with HCM6 edition. Another thing that we have in HCM is that now we can have urban streets with multiple roundabouts as basically the boundary intersection between links that we have. Of course, we do signalized intersection. Maybe this is one of the things that HCS is famous for, that we can model all different configuration and the signals, if that's actuated, semi-actuated, pre-time. And also we provide a very comprehensive optimization module along with our signalized intersection modules that enable the users to optimize signal timing, varying different parameters. There's a menu of different items that we show to the user, what are the things that they want to vary. A genetic algorithm-based optimization method invokes and tries to optimize signal timing configurations. Another big thing that HCM can do, especially HCM in the HCM6 edition, the number of its variation has been increased, is the analysis of alternative intersections. And that includes RCOTs, restricted crossing U-turn, MUTs, median U-turns, as well as DLTs, displayed left turns. These are all intersection types that you can use HCS to analyze them and see, basically to find out what is the level of service that they're operating under, and basically consider your alternative or your treatment scenarios. Interchanges is another thing that HCM methodology, it has a methodology for, and HCS can analyze. Basically, HCS can model DDIs, diverging diamond interchanges, as well as classical diamond interchanges, park close, and SPUI, single point urban interchange. So with that said, I want to pause here for a second, open HCS, and sort of go over different modules that we have in HCS and do a quick demo. It's not really a demo, maybe it's more of a showcase. All right, so once you, let me make sure I'm sharing my screen. Fabio, are you able to see my screen with HCS?
Yeah, I see it.
Okay, perfect. So once you open HCS, basically, this is the main menu that you will get. And the reason that we have designed this menu in this way is that because we want to sort of guide the user to the appropriate type of analysis or modules that they want to access to. So as you can see, we have streets, basically is our urban streets method that we have our streets and reliability methodologies. And then we have stop controlled methodologies, we have roundabout. And then on the right side, we have freeways, again, freeway facilities, as well as reliability, and highways, multi-lane highways, as well as two-lane highway. And then we have another section, we call it tools, but it basically provides you with a lot of useful tools around HCM. So we have this HCM reference guide. That's a guide that we have put together at McTrans Center. It's more of a guide on how you can do the analysis in HCS. Then we have another tool that provides you with a service volume based on the desired level of service that you are looking for. It provides you how much volume different facilities they can serve. Then we have another actually tool that we are basically giving for free. It's called Highway Safety Software, HSS. This software is basically similar to HCS, but it basically models methods that we have in Highway Safety Manual, HSM. And then we have another tool for MUTCD guide, as well as Transit 7F analysis for optimizing signal controls. So with that said, I want to actually maybe just go into two of the modules, and I want to basically go for, let's say for freeways, I want to go to the freeway reliability basically module. And I'm going to open one of the files that previously I have created. And as you can see here, this will open this screen for you. And this screen is very similar to all the screens that we have in HCS, basically providing you with sort of a process flow on the top. So for example, if you are unsure, what are the things that you need to do the first, or you are not sure about the sequence of, doing basically putting different things on top of your model in HCS. HCS basically takes advantage of like a simple type of process flow on top that if any user takes it, basically they will make sure that they're doing everything right. So I wanted to use this module to do my demo. The main reason is that I want to highlight this, unique methodology that HCM provides, and that is travel time reliability, and sort of highlight, what are the inputs, how that thing works, and how we can get performance measures and so on. So for this example, I'm using one of the examples in the HCM. This is what we have in chapter 25, example problem 1. And the first step in travel time reliability analysis is that we need to characterize our base case, or it's called in HCM seed file. And seed file is basically is your single day analysis that you want to take that and build other, days of, the operation of the facility, including non-recurrent source of congestion on top of that. So as you can see in our menu, the first step is to basically take that. In order to simplify this process, we are asking to load basically, we're suggesting that you load your base data set. Basically, we open another single day, facility analysis here. So automatically it's saved in my reliability analysis here. As you can see, it includes this facility, if I'm not mistaken, with 11 segments. But then let's move forward on this menu. The next thing that we have to provide basically, HCS is some of the information related to some generic information related to reliability. We need to say what is our reliability reporting periods, when this 1 year starts and ends, or if that's 1 year or maybe 3 months, 6 months, whatever that multiple days time frame it is. And then if we select that, it will show how many days on each month we have for those selected days in a week, and then what the reliability methodology in the HCM basically will model in terms of scenarios. So for example, in January, we have 23 basically weekdays from Monday to Friday, but this HCM methodology is going to model 20. And as you can see, really these numbers are very close, meaning that pretty much every scenario in the freeway reliability analysis represent one actual day, pretty much. Next thing, independent of everything else that we want to model, we want to basically provide probabilities for different weather types that we have. As you can see in top table, we have all those probabilities. I know that if you look into this, it's going to feel very hard to come basically to get these data. The good thing is that HCM has two databases for weather conditions, one for freeways, one for urban streets. Freeways we have about the 100 largest metropolitan areas weather probabilities in HCS already embedded. For urban streets is top 250 largest metropolitan areas. So we can come here, basically we can select where is the closest location to our freeway and basically extract all those probabilities. And then once we extract those, we need to let HCS know how we want to model these different weather conditions, basically providing HCS with the reduction in capacity and speed and maybe demand when we are seeing these weather events. We will provide this as adjustment factors to the actual free flow speed and capacity and demand that we have. These numbers, again, are pre-filled with default numbers by HCM, but if you have access to basically site-specific location, we can use those. Next thing is that we want to tell basically HCS that how our demand fluctuates in different days in this 1 year that we want to do the analysis for. HCM basically characterizes this as if demand changes by day in a week as well as months in a year, and we provide some relative adjustment factors so that we change the demand compared to what we have for the seed file. Next item that we have to provide when we want to create reliability scenarios is that we need to mention how our incidents are consistent in terms of their severity level. For example, if they're a shoulder closure, 1-lane closure, 2-lane closure, etc., and like what is the distribution, and also what are the distribution in terms of like duration, if we want to basically model those in our scenarios. Again, we need to mention what are the capacity and speed adjustment factors whenever these incidents as one of our biggest, actually, non-recurrent source of congestion occurs. And at the end, we have this table that we need to say how much is the expected number of incidents that we'll see in every day. If we have these numbers collected from field, that would be great. We can enter them here. If not, HCM provide us with a method to sort of estimate these numbers. It's called Hertz model. And then another two source of non-recurrent congestion are work zone and special events that I want to skip over them. And pretty much I want to go to the end and basically show you the results and the reports. Basically here at the end, what we are seeing is the output of the HCM reliability methodology. As you can see here, I guess the first thing that maybe we need to look into that is the distribution of travel times that we created by modeling different scenarios, by characterizing different scenarios, modeling all these non-recurrent source of congestion on top of that. And then off of these distributions, we have key reliability performance measures that are reported here, such as PTI or 95th percentile TTI, reliability rating, misery index, and so on. So with that said, I want to maybe pause here. We have about a couple of minutes before we finish this session.